Alright, so in the previous lectures, we have already introduced the hardware level for the storage devices as well as equipment that can be used for DBMS, right? And in this page as well as in the following pages, then we will be focused on how to store the data as well as represent the data in the DBMS. So normally for most of DBMS, we will have one storage manager, right? The storage manager is responsible for maintaining a database files. So the DBMS storage manager will organize all the files as a collection of pages. What kind of data we can store on these pages? Some examples are shown here, like fixed size blocks of data, as well as it can contain some tuples, metadata, schema of the relations, right? Indexes, as well as some log records. And most systems do not mix the page types, while some systems may require a page to be self-contained. It really depends on the system we are using. Besides organizing files, DBMS storage manager will also be responsible for track data read from and write to pages, as well as available spaces in the system. And the DBMS storage manager can use different organization methods for storing or for maintaining these files. Now they can use this heap file organization, which can organize the file into a heap, right? And they can also use the sequential or sorted file organization instead. And they can use the hash file organization as well, which will be much faster. Okay, so this is about storage manager we can use for maintaining the database files. Here in this page, we mentioned a heap file. What is a heap file? The formula a heap file is an unsorted collection of pages where the tuples are stored in a random order. In other words, we can get and delete the pages, and we can also iterate all the pages. However, here we are maintaining the files in an unordered manner, right? Therefore, we may need to have some metadata to keep a record or keep track of which page exists and which one doesn't exist, as well as the free space available for the pages. So we can use two different ways to represent a heap file, like the linked list as well as the page directory. As to representing the data we have in the DBMS, here we need to clarify the terminologies we use in the lectures. So here we need to differentiate the DBMS versus the file system, right? File system is one system used in the operating system for maintaining the files. So the DBMS may also need to handle the files, however, we call some of the information in a different manner. Now for the data element or the attributes, in DBMS, we can name them as attributes, right? We mentioned before in the SQL. However, for the file system, we can say this kinds of element as a field. And for the records, we can call them as tuples in DBMS. It denotes a specific record we store in the DBMS, right? As to the file system, we can just call them as a record. And to the connection of the records, we can name them as a relation, right? Because if we have multiple tuples belong to in the same format of the same category of the entities, then we can name them as a relation. However, for the file system, for the connections of the record, we can name it as file instead. So they have different terminologies to be used for different systems. And at the bottom of this page, we also show you with the example for creating a table about product in the DBMS. I remember we have shown this before, right? When we talk about the SQL. So we can create a table for products. And for the product, we have 4 attributes to be declared. The first one is the PID. The second one is the name of the product. The third one is the description of the product. The last one will be the maker of the product. These 4 denotes the attributes, right, of the product. And the PID, the attribute, its type is int. And we also declare this one to be the primary key for the product. In other words, for different products, they may have different PIDs, right? And the name is a char20. We declare this attribute to be a string. The length is 20. And for the description of the product, we also declare this one to be a string. And here we use var char 200. In other words, for the description of the product in text, the maximum length will be 200 chars, right? As to the maker, it is a char10. It is also a string. However, we declare this maker as a foreign key reference to the component, right? It is another table, right? And this maker will be referenced to the name attribute in the component relation. So in this declaration for the product relation or the table, this 4 denotes the attributes, right? If we have some concrete products like an iPhone, like an iPad, as well as some other products to be stored for the products into the product table, then they denote the tuples, right, in the DBMS for the products. And all the tuples for the product that together will define a relation for the products, right, which will be the relation as shown here. For storing these kinds of information into files, then these elements or attributes will be named as fields. For some concrete tuples, they will be named as records. And the collection of the product relation, there will be a file to be stored. So we have different terminologies to be used for different systems.